Okay, good morning, afternoon, or evening. Welcome back to Mr. Morrow's Algebra class. Today we're going to continue investigating the power of slope. It's not called slope, it's called direct variation, but it's the power of slope that is going to determine what is called a direct variation. Okay? Let's think about it this way, guys. The time it takes to hear thunder varies directly with the distance from lightning. Think about what that says before we look how we model that in an equation. The time it takes to hear thunder varies directly with the distance from lightning. So what would that mean to you in your head when something varies directly with something else? What do you think that means? For example, if I tell you working out varies directly with your weight, or the amount of studying varies directly with your grades. How do you think varies directly means? It's not equal, you're thinking though. It's kind of a cause and effect, yes. When something's varying directly, okay, as one thing is increasing, the other may be increasing, okay, or vice versa. So when you have a direct relationship, okay, you're multiplying some value called the constant to the independent variable called x. So in this case, the time it takes to hear thunder varies directly with the distance from lightning modeled by y equals 1/5 x. Okay, y equals 1/5 x. So what does this mean? That means that if x is 5 miles away, how long does it take to hear it? 1 second. Very good. Okay? So that's a direct variation. You have this slope, which in this case is called the k, or the constant of variation. And this constant of variation is going to determine if y is going to increase or decrease. Y is the distance in miles. Or actually, I'm sorry, we reverse this. Y is the distance in miles. X is the time it takes to hear the thunder. So if it takes 5 seconds to hear the thunder, how far away is the lightning? Guys, if it takes 5 seconds to hear the thunder, how many miles away is that lightning? Okay, y equals 1/5 times 5, which is 1 mile away, guys, not 25. You got to learn how to evaluate. You must plug into the correct variable. Okay, now, a direct variation is a relationship that can be represented by a function in the form y equals kx. K is your slope in this case. Notice that in a direct variation, there is nothing being added to the x or the y. There is nothing being subtracted to the x or the y. There is only something being multiplied to that x. Okay? So direct variation, the function rule is y equals kx, where k cannot equal 0. If k equals 0, then that means there's no slope, and if there's no slope, that means that it's just a horizontal line. Now, the constant of variation for a direct variation k is the coefficient of x. Coefficient, remember, is the number being multiplied to x. It is the slope of this function and can be found by dividing y by x. So if I need to find k, I just divide y by x, and then I will find my k. So I have two formulas that I work with. I have the direct variation, which is y equals kx, and I can solve for k by dividing y by x. Okay? I promise all of this I'm going to put together now. It's all going to come together now. You guys with me so far? Okay. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals kx, where k is not equal to 0, it represents a direct variation. Nothing can be added to x or y. Nothing can be subtracted from x or y for it to be a direct variation. Let's look at some examples here. Direct variation concept. As x increases, y increases by the same factor. If x decreases, y decreases by the same factor. They're not equal, but it's by the same factor. And k is constant, so it remains the same for every ordered pair x, y. For example, does the equation represent a direct variation? If so, find the constant of variation. Well, if it's going to be a direct variation, when we solve for y, it has to be in the form of y equals kx, and k is my constant of variation. So for a, to solve for y, I divide by 7. So y equals 2/7 x. Is that a direct variation? Yes. What's my k? 2/7. Very good. So that means as x increases, y will increase by a factor of 2/7 of x. How about for this bad boy? I'm going to subtract 4x to both sides. Now I have 5y equals negative 4x. Divide by 5 to both sides. Y equals negative 4/5 x. Is that a direct variation? Yes, nothing is being added to or subtracted from the x or the y. What is my k constant of variation here? Negative 4/5. Very good. So y will increase as x increases by a factor of negative 4/5. Over here, I'm going to subtract 4x to both sides. 3y equals negative 4x plus 8. Divided by 3. Y will equal negative 4/3 x plus 8/3. Is that a direct variation? No. Why? Because you're adding this 8/3. So that is not a direct variation. No. How about for this bad boy? Divide by negative 3 to both sides to get the y alone. Y equals negative 2x plus 3. Is that a direct variation? No, because you're adding that 3. So first things first, everyone understands how to look at an equation, solve for y, and determine if it's a direct variation or not. We're good there? Promise. Awesome. Let's move on. Now, here's where just some evaluating comes in. Remember, evaluating. They're going to give you values, and you plug it into the equation and solve for the unknown. Suppose y varies directly with x. So you know it's a direct variation, so this is the equation they're working with. And y is 35 when x is 5. What direct variation equation relates x and y? Then what is the value of y when x equals 9? First things first. I have an x and I have a y, but what don't I have? A k. If you remember, k equals y divided by x. So k in this case equals 35 divided by 5. So k equals 7. So my direct variation function, you got it, variation is y equals 7x, where k is 7, the direct variation. So as x is increasing, y will increase by a factor of 7. Does that make sense, boys? Now, part B. Find y when x is 9. No big deal. Y will equal 63 when x is 9. Did you guys see that? Okay, super duper. Example 3. Suppose y varies directly with x. So we're talking about y equals kx because that's a direct variation. And y equals 10 when x equals negative 2. What is the direct variation equation? Relates x and y. And what is the value of y when x equals negative 15? Well, let's find my k. K is y over x, which is negative 5. So my function, my direct variation function is y equals kx, which is negative 5. And what is y when x is negative 15? Well, y will be negative 5 times negative 15. So y will equal, very good, thank you, 75. It's not that bad, is it? Now, you do have to follow directions. You do have to follow procedures. Does anyone have a question before I continue? Okay, thank you, gentlemen. Now, remember that if a constant of variation is the same for each pair of data, the relation is a direct variation. So tell whether each tell whether each relationship is a direct variation. Remember, guys, k equals y over x. All right, guys, so let's check. Let's see if every y over every x equals the same thing. So 6 over 4, that reduces to 3 halves. 12 over 8, that reduces to 3 halves. 15 over 10, that reduces to 3 halves. So is the k constant here? Yes. What is my direct variation? Y equals k, which is 3 halves over x. Does that make sense? Okay, let's see over here. My k is y over x. So let's see. I got 3.2 divided by negative 2, which is negative 1.6. I got 2.4 divided by 1, which is 2.4. And I got 1.6 divided by 4, which is 0.4. Are these all the same k? So is this a direct variation? No. 2.25, let's look at C. 2.25 divided by negative 3 equals negative 7.5. Negative, whoa. Not, it's negative 0.75, sorry. Negative 0.75 divided by 1 is negative 0.75. And negative 3 divided by 4 is negative 0.75. So is that a direct variation? What is the equation? Y equals, that's my k, negative 0.75, x. Beautiful, beautiful. Negative 10, guys. Okay, so remember k equals y over x, so negative 10 over 2.5. Then I've got, that equals negative 4. Negative 20 over 5 equals negative 4. And negative 30 over 7.5 equals negative 4. So my k's are the same, so it is a direct variation. Y equals negative 4x. And that's it. Thank you very much. I hope you learned a lot. Have a great day.